When I was a little kid, I would look up at the sky and wonder if one day we could take humanity out to the stars. Throughout the years since that, I have heard a lot of people say we should not spend so much money on the space sector, and that there is nothing to find out in the universe. But they need to grow out of the naivety to realize the true importance of space travel, and that one day we will have the capabilities to take humans out to the stars. With the universe expanding faster than light speed, there is bound to be planets and other celestial objects out there worth to study and inhabit. Hi, I'm Dr. Paul Hertz, the Director of Astrophysics at NASA, and over the years, I've come to the conclusion that space travel is one of the most important aspects of human progress, and I believe that the space sector should be funded more. To get a brief understanding of the history of space travel, we have to turn the clocks back 53 years to when the first humans stepped on the moon. Apollo 11, which carried Neil Armstrong, Buzz Aldrin, and Michael Collins, sent the first humans to the moon, although many people nowadays still believe it was faked, which seems ridiculous considering today's spaceflight capabilities. During this event, as Neil Armstrong took his first steps on the moon, he said one of the most well-known quotes today: "That's one small step for man, one giant leap for mankind." That event was a threshold for future space endeavors, which included the ISS, Hubble, and numerous space probes that had been sent out to gather data on planets. 3 years later, in 1972, Apollo 17 took another group of astronauts to the moon, which was the last time humans had been on the moon. This year will mark 50 years since any human has stood on any celestial object, which seems a long time considering our spaceflight capabilities. However, one major reason for this are the costs of such a mission. Before the turn of the century, getting the spacecraft into LEO, low Earth orbit, which is an orbit approximately 160 to 1,000 kilometers from the surface, was unreasonably expensive, and NASA were only able to achieve a cost of $54,000 per kilogram with their space shuttle. Whereas over time, it has dropped down significantly, and nowadays, SpaceX are able to launch their Falcon 9 rocket at a cost of only $2,700 per kilogram. This is highly due to the use of reusable rockets, as it majorly cuts down on the production costs. To reuse rockets, a landing pad is designated for the boosters to fall back to and land on, and once landed, it will be taken for maintenance and preparations for its next flight. With launching rockets becoming dramatically cheaper, it only makes sense to invest more money into building rockets, as we would then be able to cut down prices even more, and soon enough, launching rockets could have almost zero cost. Now that we are able to launch rockets at much lower costs, we have to address where we would go if we were to send humans out into space. As mentioned earlier, we know that the universe is expanding faster than light speed. We know this thanks to Hubble, and we can apply Hubble's constant to measure how far something is moving away from us. The main option will be to inhabit and terraform a planet. From decades of research, many plausible options for inhabitable planets have been found, which include Proxima Centauri b, Kepler-69c, and Teegarden Star b. The reason that finding and inhabiting these planets are so important is that, as all of you would know, climate change and other environmental issues are becoming increasingly worse problems, and within a century, the Earth could be near uninhabitable, and these effects will be effects that cannot be reversed. Our only option then will be to find a planet B. Many of you would counter my statement by saying, "Oh, but these planets are not 100% like Earth, they are not 100% inhabitable." While this is true, the science would allow us to terraform these planets. For example, if a planet was too cold, we would be able to quickly warm the planet by bombing the poles with nuclear weapons. Because of this, when finding planets, we would be able to consider less factors, creating a broader range of planets to inhabit. Aside from inhabiting a planet, we also have the option of building special space structures that will sit in orbit of a planet or in Lagrangian orbits of two bodies and allow humans to live on it. A Lagrangian orbit is an orbit where an object is positioned between two celestial bodies at the point where both the gravitational pulls are equal and allow the spacecraft to stay stationary between the two bodies. Some examples of these hypothesized spacecraft are halos, ringworlds, and topopolises. The reason these innovations could be so vital is that we can counter issues such as overpopulation and global warming, and have set number of humans living on extrasolar planets or on these space structures. Another major humanitarian issue we have to consider is that we have limited access to resources, and within several decades we could run out of essential minerals and resources, which we need to build infrastructure and keep economical and social factors in place. You might ask how this is related to spaceflight. Well, spaceflight will be able to combat this issue through asteroid mining. I won't go into the process of how asteroid mining works. However, there are some implications of asteroid mining that make an endeavour worth the time, money, and effort. Asteroids contain minerals such as iron, nickel, iridium, palladium, platinum, magnesium, gold, and the list goes on. In addition, many asteroids also contain large amounts of water, which can be extracted. A relatively large asteroid, such as 16 Psyche, could contain enough iron and nickel to cover human metal needs for millions of years. And if we were to only mine 0.1% of the minerals on an asteroid, we will still end up with about 100 times more than if we mined the same amount of ore on Earth. If we were to receive the funding to pursue asteroid mining, we would be able to supply an almost never-ending amount of minerals and resources, which would fix our current issue of running out of minerals and resources on Earth. Essentially, what I'm trying to get across here is that if we were to receive extra funding and support within the space sector, we would be able to reach spaceflight capabilities that would allow us to solve many humanitarian issues that exist, such as global warming, overpopulation, and limited access to resources, just to name a few. And in addition, spaceflight is only becoming cheaper as time passes, and with extra research, costs of space travel could drop even further. All this can only happen with the support of governments and extra funding. Thank you, and hopefully one day we'll be up there in the skies.